Okay, so one application of this totally or perfectly inelastic collision is that of a ballistic pendulum. So what is this ballistic pendulum? So this ballistic pendulum is a device that is used to measure the speed of a projectile. So in this case, let this be let this projectile be a bullet. So this is a bullet. So, pangitaon na to ang speed sa bullet. So, what happens here is that when this bullet is fired into a large block, so kani siya, this is a wood that is hanging, just hang by two strings, it's suspended like a pendulum. So, as a result of the collision, pag fire sa bullet, padulong sa wood, so what will happen? The wood, which is suspended like a pendulum, will swing. So, ma-embed si bullet dito sa wood and it will swing up to a certain height. So, let that maximum height be h. So, for example, in this case here, the bullet, any projectile usually has a smaller mass compared to the block of wood. So let's say that the bullet here is a mass of 0.005 kilograms. That's 5 grams or 0.005 kilograms. And let's say that the block of wood has a mass of 2 kilograms. So gifire si bullet at a certain initial velocity b. And then what will happen is, ni-swing si block of wood, na-embed si bullet sa block of wood, and it swings up to a maximum height h. Pag abot niya diha sa maximum height, ni-rest og kadiyot si block of wood, which is now containing the bullet. So supposing we are looking for the initial velocity, or the velocity of the bullet before the collision, before siya na-embed sa block of wood. So let that be V sub B. Okay, so we have here two parts. So in the first part, momentum is conserved. So the total momentum before the collision is equal to the total momentum after the collision. But since initially the velocity of the wood is 0, so we can cancel this out. This is 0. And since after the collision, na-embed naman si bullet ni block of wood, so let's say that they share the same final velocity or the velocity after the collision. So after the collision, the velocity of the block of wood is equal to the velocity of, the bullet is equal to the velocity of the block of wood, and let that velocities be b. So therefore, the velocity of the bullet before the collision is equal to the velocity of both particles, the block of wood and the bullet, after the collision, times the summation of their masses divided by the mass of the bullet. Okay, so in the second part, the mechanical energy is conserved. So this is part 1. Part 1, momentum is conserved. So since this is an elastic collision, so we cannot expect that kinetic energy is conserved, but mechanical energy is conserved. So unsay make up sa mechanical energy? Ang kinetic ug ang potential energy. So if we choose nga ang y, ang point of reference would be kadong na 0 ni siya here. This is the point of reference, kani siyang point. So y here is equal to 0. That is the point of reference. So when the pendulum hangs vertically and then si y is equal to h, pag abot niya diri sa maximum point, wherein ni-rest kadiyot si pendulum. So when the pendulum projectile system reaches the maximum height. So the total mechanical energy, which is the kinetic energy, plus the potential energy just after the collision, is equal to the kinetic energy plus the potential energy Okay, at the maximum height. Okay, at maximum height. All right, so that just after the collision, the they have already no the same no shared velocity for the block of wood and the bullet, pero meaning katong na siya sa ubos lang, katong na siya here. So pag abot here sa ubos siya, nagbitay na siya si block of wood. Okay, na-embed na si bullet here. So kaya na po man siya there sa ubos, the potential energy is 0. But they already share the same velocity here, no? So 1/2 v squared, which is the velocity of both no after the collision, times, so this is already the summation of their kinetic energies, times the mass of the bullet plus the mass of the block of wood. Okay? And then that's equal to the kinetic energy plus the potential energy at the maximum height. So pag abot niya sa maximum height, okay, supposing na siya here. Okay, the block of wood, and I mean the bullet is already embedded in the block of wood. So ni-erase man siya. So at that point, si kinetic energy na pod ang 0, right? And it already has a potential energy silang duha. And the potential energy of the two is, di ba, that's what is potential energy? PE equals mgh. So gh is common, so you can factor out acceleration due to gravity times the height, which is the maximum height reached by both particles, and then you just add their masses. So mass of the block of wood plus the mass of the um, what do you call this? Mass of the bullet times the mass of the block of wood. So we can just cancel that out. Therefore, the velocity of or v squared is equal to 2gh, or the velocity is equal to the square root of gh. Okay, so this is another equation. So unsa ganin siya, this is now the final velocity. So okay, wala man ta kahibaw sa final velocity. Okay, so supposing this is equation number 1 here in our when we solve for the momentum, no, na conserve si momentum. So here we are, remember that in this problem we are looking for the initial velocity of the bullet. So the shared velocity is v. So since we cannot solve yet for the initial velocity of the bullet because we don't have the final velocity, then we will solve first for the kadong final velocity. So that's what we did here when we solved for the final velocity using the conservation of mechanical energy. So let this be equation number 2. So substitute equation number 2 to equation number 1, then the velocity of the bullet is equal to square root of gh, okay, times the mass of the bullet plus the mass of the block of wood divided by the mass of the block of wood. Okay, and then you just substitute the values. So square root of acceleration due to gravity is 9.81 meters per second squared times the height of, well, the maximum height reached by both is 0.03 meters. And then the mass of the bullet is 0.005 kilograms plus the mass of the wood is 2 kilograms divided by the mass of the bullet, which is 0.005 kilograms. So therefore, the velocity of the bullet when it was fired is equal to, let us just solve that using our calculator, 0.005 plus 2 times the square root of 9.81 times 0.03 divided by 0.005. So the velocity of the bullet, after or before the collision happened is 200. Wait, may kulang. I did not include the 2, sorry. So wala 2 diri. So dapat na ani siya ay 2. So times 2 pa ni siya. Okay, so the velocity is 307.6483 meters per second. So this was the the velocity of the bullet before it was fired, before it was embedded to the pendulum.